Today we will discuss about 1 to 8 demultiplexer. So in previous lectures we discussed about 1 to 2 basic type of demultiplexer. Then we discussed about 1 to 4 demultiplexer. So in continuation of that series, today we are discussing about 1 to 8 demultiplexer. So as we know that here the number of inputs always 1, number of outputs 8, this one, it means 2 raised to power 3, and we again name it as a D node D1 up to D7. This is input, say I. Now number of selection lines, number of selection lines is equal to 3, because in previous lectures also we told that whatsoever the power of 2, this 3, that much number of selection lines we need. So 3, and these are the selection lines which actually decides the output through which the input is directed. So this is first point. Second point is its block diagram. Block diagram we have this is 1 to 8 demux. This is say input I. These are outputs 1, 2, 3, 4, 5, 6, 7 and 8. So D node D1, 2, 3, 4, 5, 6 and obviously 7. And how much number of selection lines? 3. So S0, S1, S2. These are the number of output lines, and these are the selection lines. So this is the block diagram. Now we will discuss about its truth table. Truth table, we understand that we have selection lines S node, S1, S2, and the outputs. Suppose these are the selection lines, and outputs we have D node D1, 2, 3, 4, 5, 6 and 7. See this is the input. Input is I. So this is the basic requirements for the truth table: the inputs, the outputs, and obviously the selection lines. The order in which we write these outputs, it may differ also, means for your convenient, if you want to write it as D node D1, D2, D3, 4, 5, 6, 7, then obviously that is also correct, and then at that time you will get the circuit diagram according to the truth table values, the order in which you have assigned it. So when now we have to take, because there are 3 selection lines, so number of combinations can be from 0 to 7, means total art. This is 0, 1, 2, 3, 4, 5, 6 and 7, because 3 selection lines, and if we have 3 inputs, then the number of combinations can be 8, 0 to 7. So this is input 8 times 1, because the input remains same, 3, 4, 5, 6, 7 and 8. Now when S naught is equal to 0, obviously the output will be directed, this D naught will be selected for the output for the input. So when S naught is equal to 0, 0, it means this input will be directed through D node, and for others it is zeros. For 0, 0, 1, obviously D1 will be selected. Then for next combination 0, 1, 0, D2, then D3, then D4, 5, 6 and 7. So diagonal elements, you see, all the diagonal elements of this 8 by 8 matrix will be equal to 1. So others will be zeros. So you can complete this truth table. One, 2, 3, 4, 5, 6, 7, 8. So this way you can complete this truth table. Only zeros will be added to it. Now the next point is the fourth point, that is about its Boolean expression. So Boolean expression, we have to again write it for D node, then for D1. So we will write the Boolean expression from the truth table, and I also let you know how to write the Boolean expression in the previous examples in 1 to 2 and 1 to 4, but I will write it for 2 or 3 outputs. Say for example D node. D node means I input remains the same. S2, S1, S node, both these 3 variables are zeros. So S2 bar, S1 bar, S dot bar, these are in complement form. And we also know that we need to have one enable input which is at active low, so En bar. So in truth table also we can add one another column En, which is enable, and this is at active low. So 1, 2, 3, 4, 5, 6, 7, 8. So this should be at active low. And when it is 1, so then all the outputs will be equal to 0. Means when En will be equal to 1, means active at high, but it is not activate at high, it is activate only at a low value. So when En is equal to 1, whatsoever is the input, whatsoever the combination of these selection lines, the outputs for all these AND gates will be 0. So we can also now add one enable signal here, En, which is at active low. Okay. Now for D1, same way we can write it as I remains the same. Now see, only S node is equal to 1. See, only S node is equal to 1. Mean S2 complement, S1 complement and S node, and this is enable. Say D2, this comes out to be only S1 is 1. Both these are zeros. So I S2 complement, S1 and S node complement and enable. For D3, S2 is the complement. For D4, first write down all the complements. This is I, this is S1, this is S node, this is En complement. Now next, S2 is 1, so means S2, these two are zeros, So S1 complement, S0 complement, and En for D5, I, S2 1, S0, S1 is 0 and S node is 1, and D6, S2 is 1, okay, S1 is also 1, and S node is 0. So this is complement and this is En. D7, all ones means no complement to any control variable, and this is enable. So this is the Boolean expression for all the outputs, and finally we can draw the circuit diagram of this multiplexer. We will show you only few of them. Say for example, this is first and this is second, means this is for D node. This is for, say for example, D1. You can draw for all, but because in previous lectures I have shown you that how to draw the circuit diagram, so we will now write for only these 3 AND gates. So this is input I, which remains same for all the AND gates. So this is also I, and this is input, because input is same to all the outputs. Now we have 3 selection lines. This is, say for example, S node, S1, and say this is S2. For D node, all complements. So this complement, and this complement. Now for this is for D node. For D1, only S node as such. Only S node as such. And S1 and S2 complement form. This is complement. So this is one. This is also complement, and this is draw like this. Okay. And for the last, for D7, S2, S1 and S node direct. So these are direct values. So this is S node, S2, this is S1, and this is S node. Okay. So this is the way how we can draw the circuit diagram for the rest of the AND gates also. Say for example, we have this enable, which is at active low. So one inverter we require, and that also is fed to all the AND gates, because you have to take these AND gates bigger, so that because you require 1, 2, 3, 4, 5 inputs, so you have to take this AND gate of somewhat bigger in size, so that you can have a clear circuit diagram. But because in previous lectures I have shown you that how to draw the circuit diagrams, so in this case we are drawing it for only 3 AND gates, and rest of the connections you can do yourself. So thanks for watching.